Hey, this is Mark from Mobile Diesel, and I thought this was going to be a super interesting repair job. I kind of had a eureka moment last time I was here, and I thought I would make a YouTube video out of this one. We're going to talk about how a difference in voltage creates all sorts of problems. I call it minimum threshold voltage has to be met. But really, it's not only voltage, it's also amperage. There has to be a minimum threshold voltage which reflects a healthy amperage flow. And what's happening here is I have a customer that has a motorhome with a 8.3 Cummins ISC motor. It is an 8.3. It doesn't say it here, but it is an 8.3. And this is a schematic that Cummins is famous for making. They make them for all their ECM hookup. So this is really an ECM wiring diagram. What they do is they provide a motor for the original equipment manufacturer. They give them a plug on the ECM, and then they have their own for their own sensors needed to make the motor run. So all the rest of this is the customer, and then this dotted line here is the Cummins ECM. And these guys here are for up here, and the rest of this is for over here. Now, I've been using these things forever and ever, and I used to buy them directly from Cummins at the parts counter for between $8 and $15. They would come laminated with binder holes. And now everybody has to work off their phone, but because I was making a video and because I'm sentimental to these old school things, I actually printed one out and laminated it. I have a laminator and all that at my office. And so I'll keep this in my filing in this 3-ring binder I have of these. I've got like 30 years worth of these things. But this particular diagram is for 2 computer setups, the 394-4105 and then the 394-4125. Okay. Anyways, what's going on? So you've got a situation where the customer is struggling with the motor dying. Also, sorts of fake codes are being displayed on my scan tool, and it's saying it needs all sorts of things, but none of it is accurate. What's happening is you're supposed to have battery power at position 50, ignition battery power at position 5, and additional battery power at positions 38, 39, and 40. So if you look at the ignition switch here, and we've got a 5 amp fuse, follow it all the way over, and that's position 5. And then we have the battery, and you follow these guys over, and 4 make it to the main harness plug. 38, 39, 40, and 50. So when I had the computer codes and they were saying low voltage signal to the lift pump and all that, and I could hear the motorhome wanting to die, it's just stumbling. And I'm looking at my scan tool, I'm noticing that the battery voltage on the scan tool is lower than what I measured at the battery when I thought I was checking for bad grounds and battery connection. So I hopped into the engine compartment, I pulled the plug, and I tested position 50, and I had battery voltage, and that was accurate. And I tested position 5, which was ignition voltage, and that guy was a little bit more than 3/4 of a volt less. So it doesn't sound like a big deal, but usually what that means is when they're not reflecting, it's not only is it 3/4 of a volt less, but the actual line, this line right here, is carrying a load like a light bulb filament. It's actually creating a voltage drop, and there shouldn't be a voltage drop in the actual electrical line. There shouldn't be resistance there. The load should come from the actual electric component that it's powering, and that's where the voltage drop should occur. The wiring should not be the electrical component. That's the definition of a voltage drop, when you have an unwanted draw in the actual wiring. This should be a unclotted artery, a healthy artery. So that was reflective in 3/4 of a volt less at position 5 through the ignition key than position 50. So that's what makes this whole thing interesting. So when I jumped in the engine compartment and tested that, I was like, wow, cool. Because this is an easy fix. Like, we're going to check the fuse, and if that doesn't give me the solution, I'm actually going to create a new ignition switch signal and have a healthy relay creating a ignition signal straight from the battery in the engine compartment. But first things first, I'm going to pull this guy and see if I could figure out if this is a corroded fuse. And while we're at it, these fuses here, numbers 38, 39, and 40, these guys here, these three had no voltage going to them, no battery voltage whatsoever. I've triple checked with the manufacturer. This is the correct schematic, but something's going on. So I'm going to set up the job site, and then we're going to figure out what the hell's going on and probably end up doing some rewiring if I can't find the problem in the fuse section. And that's it for now.